Hello, Math 3 students. I wanted to give you a little help with the homework, lesson 1.4. This is page 37 in your textbook, and it's talking about this right here, the normal curve, and I copied that from your first page down on the bottom right here. So I have it right there next to me, which makes it easier. So I want to explain that normal curve one more time. A normal curve is when the data points are distributed right around the center, which is the mean. And so the average X bar is in the middle, and it's symmetric on the left side and on the right side. And it's divided into 3 sections, which each section is 1 standard deviation. So from the average, you're going up 1 standard deviation, 2 standard deviations, 3. So you always go up 3 and then down 3. So you're having 1, 2, so you're having 6 compartments. So the compartment closest to the average has the most data. 34% are in, by the way, the data is the area under the curve. So whatever this area is, that's your percent. So that means 34% of all your data is centered 1 standard deviation above your average. And 34% is 1 standard deviation below your average. And then so on and so forth. This is 2 standard deviations, 13.5%, and then 3 standard deviations, and it's getting, the points are getting further away from the mean, 2.35%. And it's the same on the way up. Notice these don't add up to 100%. The whole curve is 100%. The reason is we got these little tails that I made green, and those might be having some data points, and they might contain an outlier. That's why these are so few percent. And I figured out that the tail has, by the way, 68% of the data, 34 plus 34, are within 1 standard deviation. 95% are within 2 standard deviations. 99.7% of all the data points are within 3 standard deviations. So these are the numbers we want to remember: 68, 95, 99.7. So that leaves 0.3% for both of the tails. So 0.3% for both of the tails means that in one tail is half of it, right? Makes sense? So half of one tail would be 0.3 divided by 2, which is 0.15%. So each tail has another 0.15% of the data. All right, now let's look at the question and see if we can answer this. Analyzing a normal distribution. Make a little smaller. The scores on an Algebra 2 final are approximately, always these are approximately, all this is about, close to normally distributed, meaning most of this can be shown with a bell curve. Most of the data falls symmetrically to the left and to the right of the average, with a mean of 150. So those are the numbers you need. You need the average, the mean, and you need the standard deviation. Those 2 numbers you definitely need. So I'm going to draw a sketch of a bell curve. I'm going to start here. Don't matter how high you draw it. And then I have my average in the middle, since it's normally distributed, 150. I'm going to make that a little smaller. So the average score is 150. That goes in the middle, right? And then a standard deviation of 15. So we're going up 1, 2, 3 standard deviations and down 1, 2, 3 it's always 3 standard deviations up or down. So if I go up 15 from 150, I end up at 165. And then one more, adding 15 to it. So you always add 15 because that's your standard deviation, and I end up at 180. And that's where I want to be. What percentage of the students who took the test scored above 180? Above means we want the area to the right of 180. So we want to know how much data is contained, how many students is this area right here worth? This, all of that, including the tail, right? So then we have to figure out what are our percentages. By the way, this is the next one would be 195, I believe. That's as far as we'll go, 3 standard deviations. And each one is 15, so you can add it. If you go this way, you're gonna get lower scores, but we don't need it because we need this area above. Had it said below, then you would find all of the area to the left. Okay, so we're gonna look at our chart. So remember, it's 2 standard deviations. 1, 2. So we're gonna look at our picture and look at 2 standard deviations. So we want this part right in here. Am I making sense? I'll lie that above 2 standard deviations. So we have 2.35 plus 0.15. We got that part where my cursor is and the green part. So I'm going to add those up. What did I say they were? 2.35. Oh, I'm going to use different color. 2.35 plus, is it 0.15? My memory does not do well. Out of this one. I think it was 0.15. Yep. So those are the 2 areas, this one and then the little tail that has something like outliers. Maybe somebody had an extremely high score that would fall in the tail. So this is 0, 2, 5, 2.5 of the students. Had a score higher than 180. Okay, so then remember the area under the curve tells you the percentage of data points that fall within that region. And in the question, you will always get the average and you will always get the standard deviation. Okay. There's one question on the test that'll ask something like this. You have an average, they're giving you a set of data points and it says, how many of these data points fall within 2 standard deviations? And you would have to find the standard deviation and then look and then make one of these and look how far above and below the mean are those standard deviations. Maybe we'll find one in the textbook. We can do that one together, okay? And then we had B, so we had A and B on that question. And I think C would be also very good. We can look at that. If 250 students took the final exam, approximately how many scored above 135? So now it's not asking for a percentage, it's actually asking for how many students. Do you see the difference in the question? Here it said what percentage, and there's your answer in percent. but now it's giving me a number of students. Here we do not know how many students took the test. Okay, we only know the mean and the standard deviation. But now we know 250 students took the test. How many of them scored below 135? So I have to start all over with my curve. I need to find the percent of students who scored below 1 or above. Is it above? Above, yeah. First, find percent of students above 135. And then second, multiply that, oh, my marker by 250. Okay, so I could use this curve, I suppose. Above 35. Okay, so we got to go this way because notice the mean is 150. So we're going to go down a standard. Here we went up, standard deviation 1, standard deviation 2. This was, so we always added 15. Now we're going to have to subtract 15. So 150 minus 15 is 135. So that's the score we're looking for, above 135. So we want the curve that's to the right. All of these scores to the right are above 135. All of this, including our little tail, right? All of these students here in this set, in this area, scored above 135. Does that make sense? Had it said below, I would go this way. So now let's add up the percent. This one is 34. I'm looking at my chart again, right? So I go down from the mean 1 standard deviation. The area is what is 34 and 34, 13.5, and this and this. I got to add all of these up. So I will write down my numbers, 34, and then this one is 34. I just have to know that chart. That's all it is. So we study those numbers, 34, 34. I think this is 13.5. This is 235, 2.35, and this little tail is 0.15. I believe those are the numbers. So now I'm going to add them up. Use a calculator if you want. 34 plus 34 plus, I'm adding up all these areas, plus 2.35 plus, am I making a mistake? I hope not. And now using a calculator, I'm going to grab one. By the way, I just noticed there's a mistake. Now here's the deal. If you can tell me what the mistake is next time we're in class, I'll give you extra credit. And my answer, when I add all that up, it comes up to 84. So that tells me that 84%, that's not the number of students. This is your percent, because those numbers inside here are percentages. So 84% of 250 students, you need to change your 84% to a decimal, move it 2 spaces to the left, and then you multiply by 250. And now we get 0.84 times 250. I got 210 students. Now we have the number of students. So that's the difference. 210 students. Yeah, of the 250 students who took the final exam, 135 scored above. I mean, of the 250 students, 210 scored above. $135. And then the last question, which I didn't give you yet, but I thought about it, and maybe you can help me. I'm trying to think. So it says if 13.6% of the students received a B on the final, how can you describe their scores? And I'm just trying to think. I'm going to pause this for a second. Okay, so this is how I see it. 13.6% on my normal curve would be this area right in here, because that's 13.5. All this under here, this would be, so that would mean that the B area would be somewhere around here, which most people had a higher score than B. Notice the area under the curve is much, it's getting more and more. So this part here to the right contains, I would say, 3/4 of the data. That would mean to me that most students scored higher than a B. That's how I see that. Okay, I'm going to stop here. Good luck with that homework. Ask me more questions during class if you have to. This definitely is on the test I'm giving you next week. So study this little chart, the normal curve.